This is the lecture for Lesson 4. This section is on polynomials, and the first part of this lecture is going to be about properties. So identifying the degree, leading coefficient, and if we have a monomial, binomial, or trinomial. On this slide, you'll see an example of a polynomial. It says 4x cubed minus 9x squared plus 6x. And it says here that the degree is 3 and the leading coefficient is 4. So how do you determine the degree and leading coefficient? Well, there's some steps here. It says 1, find the highest power of x to determine the degree. So the highest power on x here is 3. Identify the term containing that highest power of x, which is then called the leading term. So this entire term, 4x cubed, is the leading term, which means then you can identify the leading coefficient by looking at the coefficient of the leading term. So in your own words then, can you explain how you determine the degree of a polynomial based on what we just did on the previous slide? So I'm not going to fill that one in. I'm going to leave that one up to you. And then we have some examples here where it asks us to determine the degree, the leading term, and the leading coefficient. Now, usually in math, when we write our answers, we put our highest degree term first. That's proper form. Now, not all of these are going to be in proper form, so you may have to look around to determine which one actually has the highest power. So when I look at the first one here, I have a third power, second power, first power, no variable. So right here, highest power. So that is a third degree. The entire leading term is negative 7x cubed, and then the leading coefficient is negative 7. We can go to the next one. We have a third power, a fourth power, and a single power. So the fourth power is the highest power. So this is going to be a fourth degree polynomial. The entire leading term is 1/5 x to the fourth, and that leading coefficient is 1/5. Last one, first power, second power, fourth power, fifth power. So again, make sure you always circle the sign that's in front of it as well. So this is a fifth degree polynomial. That entire term is negative x to the fifth. And the number that's in front of this x when it's not there is a 1 with that negative in front. So negative 1. So can we, true or false, I can determine a polynomial's leading coefficient by inspecting the coefficient of the first term. Based on this, was the leading coefficient the coefficient of the first term listed? And the answer is no, because there are times they are not listed in the proper form. Proper math form, yes, you would be able to look at that because it goes highest power to lowest power, but they are not always listed in proper form. Now, the next thing you can do is determine if you have a monomial, a binomial, trinomial, 4-term, 5-term, however many terms there are. And it's just based on how many pieces there are in the expression. So a monomial represents one term, and you can see here negative 2x to the fifth. That is one piece. It could be a number, a letter, or a combination of both. A binomial is going to have two terms. So it's going to have two pieces separated by an addition or subtraction sign. Trinomial is going to be 3 terms, again, separated by addition and subtraction signs. And you can see here, this one has a number and a variable. This one has just a number. This one has a number, a variable, and an exponent. So they can all be different. 4 terms will also have 4 terms. You'll see 4 pieces separated by addition and subtraction signs. So for this example, we just want to identify if it's a monomial, binomial, or a trinomial. If I have 8x plus 3, that is 1, 2 terms. 2 terms is a binomial. 4x squared minus x plus 25, that is 3 separate terms. That will be a trinomial. And the last one, 6x cubed, no addition or subtraction signs. This is a single piece. This is a monomial. And those words mono, bi, and tri should be familiar to you to represent 1, 2, and 3. The next part of this lecture is going to be all the operations we can do on polynomials. So we're going to add and subtract and multiply. Start with binomials. We may throw in some trinomials and go from there. Adding and subtracting polynomials is just combining like terms. The addition ones are going to be a little more straightforward because adding is a lot easier than subtracting. So usually what I do, excuse me, is I like to underline and then maybe squiggle or circle or do a different symbol around terms that are alike. So I have negative 7x cubed plus 6x squared minus 11x plus 13 that I want to add to the polynomial 19x cubed minus 11x squared plus 7x minus 17. So the first thing I see is I have a x to the third power, and I'm going to take negative 7x to the third and add 19x thirds to that. So negative 7 plus 19 leaves me with 12x cubed. So next I have a 6x squared, and I'm going to look and see if there's any like terms with that, and that's the negative 11x squared. So 6x squared plus negative 11x squared is negative 5x squared. Next one, I have negative 11x, and its like term over here is plus 7x. So negative 11x plus 7x is going to leave me with negative 4x. And then lastly are my numbers. 13 plus negative 17 is negative 4. So I've combined all my like terms together and created my polynomial. Next one, 5x to the third plus 7x squared minus x plus 9 plus the polynomial 11x cubed minus 6x squared plus x plus 3. So doing that same process again, 5x cubed plus 11x cubes is 16x cubes. I didn't need to put a plus there. Next one, 7x squared plus negative 6x squared. So 7 minus 6 leaves me with 1x squared. I have a negative x to which I want to add a positive x. Well, negative x plus positive x cancels each other out, so there's no x's that I'm going to write here. And then lastly, plus 9 plus 3 makes plus 12. All right, so with subtraction, we need to be a little more careful in remembering that we have the subtraction sign here. So I have 18x cubed minus 2x squared minus 7x plus 8. And I want to subtract that by this other polynomial, 9x cubed minus 6x squared minus 5x plus 7. So starting first with 18x cubed minus 9x cubed. I have to remember to look at the sign every time. So 18 minus 9 is 9x cubes. Now I have negative 2x squared, and I want to subtract negative 6x squared. Well, if I do that, negative 2 minus negative 6, that becomes plus 6. So negative 2 plus 6 is 4x squareds. Now I have negative 7x minus negative 5x. So negative 7 minus negative 5 turns into negative 7 plus 5, which gives me negative 2x. And the last one, 8 minus 7 is 1. Now, the other way that you can do this is distribute this negative into the entire second parentheses, and then you'll be able to line up the terms. So let me show you. 3x squared minus 7x to the fourth minus x plus 6. We want to subtract negative 2x squared minus 9x to the fourth minus x minus plus 5. So if I distribute this in, that's going to turn into a positive 2x squared. So what I'm going to do is underneath the like term, I'm going to write it, positive 2x squared. Negative times negative 9 is going to make positive 9x to the fourth. So plus 9x to the fourth. Negative times negative x is positive x. And negative times 5 is negative 5. And then you'll see here all your terms are lined up nicely to add them. So 3 plus 2, 5x squared. Negative 7 plus 9, 2x to the fourths. Negative x plus x, those are going to cancel each other out. And then 6 minus 5 is 1. And technically, the correct way to order this would be 2x to the fourth plus 5x squared plus 1. Highest power down to no power. Next up is going to be multiplying polynomials. When you did two binomials, a two-term times a two-term, you probably learned this phrase called FOIL, where you multiply the first terms, then the outer terms, then the inner terms, then the last terms. And then when you're done, you're going to add all the like terms together and simplify. So if we have 3x plus 7 times the quantity x plus 4. So if we look at firsts, that's 3x times x. Now when we are multiplying these, the variables are going to change. So 3x times x is 3x squared. So then we go outers. 3x times 4 makes 12x. Okay, then we go inners. 7 times x is 7x. And then lasts. 7 times 4 is 28. Now these two middle terms in the two middle terms are going to be like terms. So we're going to combine those together. So I have 3x squared. If I have 12x plus 7x, that's going to make 19x. And then put the plus 28 on the end. We can do the next one following that same process. So 2x minus 9 times the quantity 4x plus 5. So 2x times 4x. 2 times 4 is 8. X times x is x squared. 2x times 5, 10x. Negative 9 times 4x is negative 36x. And negative 9 times 5 is negative 45. Again, those two middle terms are like terms. They're just x pieces. So we're going to combine those together, carry the 8x squared over. 10x minus 36x is negative 26x, and then minus 45. We're going to expand now and do a binomial times a trinomial, and then two trinomials. So we can't really follow a key phrase like FOIL here. So I'm going to show you two different options that you can do. First one says to take x plus 4 times the quantity x squared minus 5x plus 8. So your first option is to follow the distributive property here. And we're going to take x multiplied into all three of these pieces. So x times x squared makes x cubed. X times negative 5x is negative 5x squared. X times 8, 8x. Then you're going to take the 4 and distribute it into all three terms. So 4 times x squared, 4x squared. 4 times negative 5x, negative 20x, and 4 times 8 is 32. You will again see that we have some like terms here that we're going to combine. So I have a single x cubed, but x squareds, I have negative 5x squared and plus 4x squared. So it's going to make negative 1x squared. For x's, I have 8x minus 20x, so negative 12x, and then a plus 32 on the end. Now, if that's a little messy for you, I can show you another way. So I have 2 terms times 3 terms, x plus 5 times x squared minus 3x plus 6. So what I do is I'm going to create a little 2 by 3 table, kind of like a window pane, and we're going to multiply it that way. So I have x and 5 times by x squared, negative 3x, and positive 6. So each box is going to be the product. So x times x squared, x cubed. X times negative 3x, negative 3x squared. X times 6, 6x. Now I'm going to take 5 times all 3 of those values. So 5x squared. 5 times negative 3x is negative 15x, and 5 times 6 is 30. Now, your like terms are going to be on the diagonals here. So these two are alike, and these two are alike. So I have x cubed. 5x squared minus 3x squared is 2x squared. Negative 15x plus 6x is negative 9x. And then I have a plus 30 on the end. And then this can expand to any number of terms. So I'm going to do that with this 3 times 3, try times try. And I'm going to make a 3 by 3 window pane now. So I have x squared, 2x, and negative 3. Going to be multiplied by x squared, negative x, and negative 1. So x squared times x squared, x to the 4th. X squared times negative x cubed. X squared times negative 1, negative x squared. 2x times x squared, 2x cubes. 2x times negative x, negative 2x squared. 2x times negative 1, negative 2x. I multiply everything by negative 3, so negative 3x squared. Negative 3 times negative x makes positive 3x, and negative 3 times negative 1 is positive 3. So just like before, your like terms are going to be on the diagonals here. So x to the 4th is by itself. Now we have x cubes. So 2x cubed minus 1x cubed is 1x cubed. Then your x squareds are on the next one here. Negative 3x squared minus 2x squared, negative 5x squared, minus 1 more x squared is negative 6x squared. Then your x's here, 3x minus 2x is a positive 1x, and a plus 3 on the end. So still working with the same process, I'm going to add in some other variables here. Got xy minus 3 times x squared minus 2xy plus 5. So the first one, I'll distribute xy times x squared. So that's going to make x cubed and a y. Xy times negative 2xy. So numbers negative 2, that's going to be x squared, and y times y is y squared. And xy times 5 is 5xy. All right, I'm going to take negative 3 into all 3 of these. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 2xy is going to make 6xy. And negative 3 times 5 is negative 15. So it looks like the only like term I have here is the xy term. So x cubed y minus 2x squared y squared. 5xy plus 6xy is going to be 11xy. And minus 3x squared minus 15. Again, if that is a little more messy for you and you want to do a table, look at how many terms you have. I have 2 terms times 3 terms. So I'm going to make a 2 by 3 window pane. X, y. The top is going to be x squared 4xy minus y squared. So I'm going to take x times x squared, x cubed, x times 4xy, So 4x times x is x squared. Keep the y. X times negative y squared is going to be negative. Keep the x and keep the y squared. No powers change. Now I'm going to take y times x squared. So y x squared, or you can write that as x squared y. It's the same thing. Y times 4xy. So 4 times 1 is 4. A single x. Y times y is y squared. The last one, y times negative y squared, is going to be negative y cubed. This one does still have like terms on the diagonal here. So x cubed. Now, like I said, this one could be rewritten as x squared y, so you can see that they match. So x squared y plus 4x squared y is 5x squared y. 4xy squared minus xy squared is 3xy squared. And then I have a minus y cubed on the end. And that is the end of this section, so you can go on and do the homework.